Auzu billahi minash shaitani rajim. Bismillahir Rahmanir Rahim. Multipath is very serious issue for the design of efficient wireless communication system. Today we will discuss some important aspect of multipath, such as limitation offered by the multipath, what are the causes of multipath propagation, and we discuss about the various limitation offered by multipath, and we also discuss about some advanced techniques to control the effect of multipath limitation for the design of efficient wireless communication systems. Multipath propagation refer to the phenomenon in which wireless communication signal travel from a transmitter to receiver by multiple paths. Each copy of the signal take a different path and may experience different delays, attenuation, and phase shift. This can introduce challenges, some serious challenges in wireless communication system. Multipath propagation can occur both interferences and fading. Constructive interferences can amplify the signal, while destructive interferences can lead to the signal completely faded or null. So intersimple interferences can occur when delayed version of the signal overlap and causing a distortion and error in data transmission. Accurate channel estimation becomes very crucial to deal with the multipath propagation. Estimating the characteristic of each path, such as delay, attenuation, and phase, can be challenging, but it is necessary for effective equalization and signal processing technique to solve the problem of multi-channel fading. Multipath propagation limits the achievable channel capacity. Fading and interferences reduce the effective capacity of the system and require efficient coding and modulation scheme to optimize the data rate. Similarly, multiple channel characteristics can vary over time due to environmental changes. Necessary adaptive algorithm to track and adopt the changing condition are required. Understanding the limitation of multipath propagation is very essential for efficient design, robust design, and reliable design of wireless communication system. Techniques like advanced equalization, diversity schemes, adaptive modulation and algorithms, and efficient channel estimation method are employed to solve these limitations and ensure optimal system design. The multipath propagation phenomenon is primarily attributed to the following factors, and the most important factor is the wireless reflection. Wireless reflection plays a significant role in causing multiple propagation. When a wireless signal encountered a reflecting surface, such as a wall, building, or a metallic object, a portion of the signal is reflected back into the space. This reflection generates additional path for the signal to reach the receiver and resulting in multiple propagations. Similarly, wireless diffraction, another important parameter for causing multiple propagation by creating additional path for the signal to reach the receiver. When a receiver signal encountered an obstruction or diffracting edge, it is spread out and propagate into the area that could be otherwise shadowed. This diffraction process leads to the formation of multiple diffraction waves that contributes to the multiple phenomena. Scattering is another important factor that contributes to the multipath propagation in wireless communication. It refers to the phenomenon in which wireless signals are redirected in various directions when they encounter irregular surface or object with a some rough surface. Scattering also occurs due to the interaction of the signal with small scale variation or irregularities present in the propagation medium itself. Here are some key limitations associated with multipath channel in wireless communication. The most important is interference and signal degradation. Multipath propagation can result in constructive as well as destructive interferences of the signal component arriving at the receiver. When signal combine constructively, they can enhance the received signal power and leading to stronger reception. However, destructive interferences can cause fading and resulting in signal attenuation or completely loss of the signal. This interference-induced signal degradation can significantly impact the reliability and quality of wireless communication. Another important is inter-symbol interferences, which occur due to delays version of the transmitted signal arrived at the receiver side with different amplitude and phase due to multipath propagation. As a result, the received signal can overlap in time and leading to the difficulty in accurately decoding the transmitted information. ISI can degrade the bit error rate and limit the achievable data rate, especially in high speed communication system. Delay speed is another issue, and delay speed due to the multiple propagation introduce delay in the arrival of the different signal component at the receiver. This time difference between the arrival of the first and the last signal component is known as a delay spread. Delay spread can cause distortion in the received signal and affect the system ability to accurately detect and decode the transmitted data. It is particularly problematic in systems with high bandwidth requirement. Channel capacity limitation, it is another important parameter, and the presence of multipath propagation impose some limitation on the achievable channel capacity. Multipath channel exhibit frequency selective fading when the fading characteristic vary with frequency. This requires the use of sophisticated equalization and a coding technique to control the effects of the multipath and maximize the achievable data rate. The complexity of this technique can limit the overall capacity of the channel, wireless channel. Similarly, complex channel equations estimations in order to combat the limitation imposed by the multipath propagation, wireless systems often employ channel estimation techniques to estimate the channel response. However, estimating the channel in multipath environment can be a challenging itself due to the varying signal strength, delays, and frequency associated with different propagation paths. Accurate channel estimation is crucial for effective equalization and decoding, and error in estimation can further degrade the overall system performance. To overcome the limitation of multipath propagation mode, wireless communication system employs various design techniques, including most important technique is equalization. Equalization techniques are used to control the intersymbol interferences by compensating for the channel distortion. Equalizers estimate and invert the channel response to recover the transmitted signal very accurately. Similarly, diversity techniques such as spatial diversity, frequency diversity, and time diversity are used to combat fading and improve the overall reliability of wireless communication. By transmitting multiple copies of signal or using multiple antennas, diversity techniques exploit the differences in the propagation path to enhance the overall system performance. Similarly, adaptive modulation and coding techniques also used to adjust the transmission parameter based on the channel distortion. And by dynamically adopting the modulation schemes and coding rates, these schemes optimize the trade-off between data rate and bit error performance in varying multipath environment. Similarly, in multiple input and multiple output antennas, basically MIMO system utilizes multiple antennas at both the transmitter side and the receiver side to exploit the spatial diversity offered by the multipath propagation. MIMO techniques can significantly improve the overall system capacity, reliability, and spectral efficiency. All these techniques are considered best practice, design practice for designing of efficient wireless-based communication systems.